Okay, so now we're going to talk about the cross product. The cross product is the other kind of vector multiplication you can do. The one we did before was the dot product. You will recall that if we had two vectors, we'll call this one A and this one B. I'm putting them tail to tail just for convenience, but remember vectors can have their tails put anywhere. That's their dirty little secret. And then theta is the angle between them. That's a theta, as diseased as it is. So the dot product, you'll remember A dot B was the magnitude of A times the magnitude of B times the cosine of the angle between them. So if theta was 0, these were pointing in the same direction, and then the cosine was 1, so that was just equal to AB if A and B were parallel. That's the little 8th grade or 7th grade geometry parallel. 8th grade geometry, actually 9th grade for me, 8th grade for you fancy TJ kids. And it was equal to 0 if, or at least for a lot of you fancy TJ kids, if A and B were perpendicular. Okay, so it was a measure of how parallel the two vectors were, okay, in that sense. So it was also equal, measure of how big they were, because you just multiply the magnitudes together, but also how parallel they are. The cross product does something different. The cross product, first of all, it's a vector. So A cross B, and this is why we call it the cross product, because it's the old 3rd grade multiplication, or well, I learned multiplication in 3rd grade. You guys are TJ kids, so what was that for you? Like 2nd week of kindergarten? When you're learning multiplication, you just draw it like that, and then later on you get into algebra and you stop, doing it all together. But this is like the old-timey multiplication, so it's back. The cross product, first of all, it's a vector. So the dot product is a scalar, but the cross product is a vector. I'm going to draw it like that, and there is the vector C. And so let's see. Actually, I've drawn that backwards, but yeah, bad, Dr. Smith. So what I'm going to do actually is I'm going to draw this going downwards. There we go. Okay, and that's correct now, right? So so if C is the cross product of A and B, then first of all, C is perpendicular to A and to B. So C points in the direction that is perpendicular to both of these. Now, two vectors together define a plane. If you think about that, think about like your xy plane. You take any old two vectors in that plane, and you can add them up to find any point in that plane in different combinations. So any two vectors can define a plane. You can see that intuitively, I think. So the cross product of those two vectors is going to point in the direction that is perpendicular to the plane. And then the other fact about the cross product is that the magnitude of the cross product is equal to the magnitude of A times the magnitude of B times the sine of the angle between them. And so if A and B are pointing in the same direction, then this is going to be equal to just A times B times the sine of 0 degrees, which is 0. So actually it's going to equal 0 if A and B are parallel, and it's going to equal magnitude of A times magnitude of B, or the magnitude of the cross product, I should say, is going to equal the magnitude of A times the magnitude of B if A and B are perpendicular. So the cross product is a measure of how perpendicular two vectors are. If they are parallel, then the cross product is 0. If they're perpendicular, then the cross product is the magnitude of each vector multiplied together. Finally, which direction, and I'm going to sort of fence off my dot product stuff here because that's, that's old hat. Which direction does the cross product point? Well, you use something called the right-hand rule. So the right-hand rule. And so what you have is you have your right hand. So here's a right hand. It is palm up towards you. I know this is horrible drawing. Okay, so your right hand, this is your right hand, here's your palm pointing towards you. And what you do is, for example, if you're doing like A cross B equals C, okay, then what you do is your thumb is A, and then your first finger is B, and you hold them in sort of that, that L shape, and then you stick your middle finger the only direction it can go that's perpendicular to these, which is in this case straight out towards the page. And so I'm going to draw a vector that comes straight out, which is C. We use this, actually let me bat that off a little. We use this circle with a dot in it to indicate a vector coming straight out at us. So to explain that, this is a vector coming at you, so it's pointing towards you. So it's really not coming at you, it's pointing towards you. And this is a vector pointing away. It's a circle with an X. Okay, so what we're saying here, and this is kind of hard to visualize, but well, I mean, it doesn't help that my drawing is horrible, but if your thumb is pointing in the direction of A and your index finger is pointing in the direction of B, and you make a right angle with those, then the way your middle finger points like straight up from your palm when you're sort of making a three-dimensional loser symbol. So this is your L, and then you've got another finger like pointing straight out at you. Then your middle finger is pointing in the direction of C. That's the right-hand rule for vector multiplication. A cross B equals C. So this all sounds kind of difficult because I've sort of explained what the magnitude is and then what the direction is, and it sounds like you have to calculate them all separately, but actually it's much easier when you do it in components, and also it gets a lot easier if you're doing it in any problem where you've got a diagram drawn in 2 dimensions, because then your cross product is always going to be in the positive k or negative k direction, and that's actually very easy. So we will get to that in the next video.